This lesson is part 1 of the double angle formulas in section 9.2. Today we're mainly going to focus on using our double angle formulas to simplify expressions. Tomorrow we're going to use our double angle formulas in verifying trig identities, which is where it gets a little bit tougher. So today we're just going to introduce how you actually can apply those double angle formulas. Okay, so in your proof notes, what we did is we took the addition formulas and then we derived our double angle formulas, and then we rewrote also equivalent forms of those double angle formulas. So if you haven't already done so, please make sure that you've already watched parts 6 and 7 of your prove it notes. That's where you're going to get a basic understanding of how to derive these formulas so that you're not just worrying about memorization the whole time, but you actually know where these are coming from and how to get them pretty quickly. So we're going to start here by actually applying these formulas. The first question says, if sine theta is equal to 4/5 and theta lies between pi over 2 and pi, so it's in the second quadrant, find the quantities sine 2 theta and cosine 2 theta. All right, there's a couple ways that I want to do this. First, I'm going to look at sine 2 theta. And knowing my double angle identity, I know that sine 2 theta is equal to 2 sine theta cosine theta. So now I need to be able to plug in a value for sine theta, which I already have right here. It's given. So I'd type in, or plug in 4/5. Now, the cosine of theta is something I'm missing. So I would find that you can draw a triangle if you want. So we're in the second quadrant here. We have the opposite and the hypotenuse here. And then this is a 3, 4, 5 triple. So our cosine here of theta, there's theta here, would be 3/5. So cosine of theta is 3/5. However, just be really careful. It's actually negative because we're in the second quadrant. So we have cosine of theta is negative 3/5. Now I can plug that in and I can evaluate sine 2 theta pretty easily. That gives me negative 24/25. Okay, next up I have to evaluate the cosine of 2 theta. Now I can use any of those equivalent forms above. I would like you guys though to make sure that you're really comfortable with cosine squared minus sine squared. Okay, this one lets you derive basically all the rest pretty easily if you can remember this. And that just comes from your addition formula, so it's not hard to get if you just do cosine of theta plus theta. So if you know that, you should arrive at this. Okay, anyhow, let's calculate. So cosine squared theta, we already know what cosine theta is, so we're going to take negative 3/5. We'll square that value and subtract 4/5 squared. So we have 9/25 minus 16/25 to give me negative 7/25. Alternatively, let's just use a different one and we'll verify that that actually gives you the exact same value. So I'm going to take, this is what I mean by how you can derive these pretty quickly, because cosine squared theta is 1 minus sine squared theta. So now you have another identity that's equivalent to cosine 2 theta, and that's, 1 minus sine squared theta. So now I'm going to plug in sine theta and square that value, multiply by 2. So I have 4/5 squared times 2, so that's 16/25. So 1 minus 16/25 times 2 is 32/25. Subtract 1 minus, or take 1 minus 32/25, and I ended up with negative 7/25. So I do get the exact same value depending on which trig identity I use. All right. Okay, in problem 2 here, it's a little bit different of a question because it says to express sine of 2 theta in terms of x. So let's just start with trying to write out the sine of 2 theta. Now that's the double angle formula, so I know I can write this as 2 sine theta cosine theta. Okay, now I obviously don't see any x's here, right? And my answer is supposed to be in terms of x, kind of similar to what we did way back in chapter 4 in semester 1, where we had to write a function in terms of just one variable, even though we might have had multiple variables in there. So we need to do something with our given here. We're going to have to manipulate this so that we know how to plug that value in. Well, I see a sine theta here, and I also see a sine theta here. So what I'm going to do is solve for sine theta. So I have sine theta is equal to x over 4. Now sine theta is in terms of x. So I can make a substitution here and say that now this is equivalent to 2 times x over 4 times the cosine of theta. All right, now how do we express cosine of theta? Well, there's a couple ways that you can do this. One, we can start with cosine squared theta plus sine squared theta is equal to 1. So solving for, or plugging in sine theta, I should say first. So cosine squared theta plus x over 4 squared is equal to 1. Now if I want to solve it for cosine squared theta here, I would subtract over x squared over 16. Okay. Okay, so let's solve for the cosine of theta by square rooting both sides. So then I'll have the square root of 1 minus x squared over 16. Now, this is positive or negative, right? Because we could get two possible solutions, but we want to go back to what we're given here. And it says that theta lies basically in the first quadrant, which means then that the cosine of theta has to be positive. Okay, it's got to be positive. And then I'm going to just simplify this so that I have a fraction here, because I realize that the denominator is a perfect square. So I can kind of simplify this a little bit if I make this the square root of 16 minus x squared over 16, and then I can take the square root of the denominator. So I have in the numerator 16 minus x squared underneath that radical, and then 4. I really can't do anything else with the numerator at all because I can't take the square root of 16 minus x squared. So now I plug that in for the cosine of theta here. So I have 2 times x over 4 times the square root of 16 minus x squared over 4. And then simplifying here, let's see, that becomes x times the square root of 16 minus x squared all over 8. So this is writing sine of 2 theta in terms of just x. Okay, number 3 is pretty similar to the first question that we went over. So you can pause this and try, actually 3 and 4 are very similar to 1 and 2. You can try these and then you can watch the video or check with the key to make sure you did these correctly, or you can just simply watch the rest of this portion here, but make sure that you do come back for this bottom part where we go over the half angle stuff. So, all right, here we go. Let's do number 3. In number 3, if the cosine of theta is 3/5 and theta lies in the fourth quadrant here, we're supposed to find sine of theta, sine of 2 theta, and cosine of 2 theta. So it's nice that they make us find sine theta because we'd have to do that anyhow for sine of 2 theta and for cosine of 2 theta. So we'll begin here by finding sine theta by drawing a triangle in the fourth quadrant. And I have the cosine is 3/5, so that makes the hypotenuse 5 here. And this opposite side would be 4 since it's a 3, 4, 5 triple. So the sine of theta is going to be 4/5. Sorry, I forgot to draw theta in. There's theta here. Okay, so we have to think about the fact, though, that the sine of theta here, even though the segment length is 4, because it's a triangle, the actual sine of theta is going to be negative because it's lying in the fourth quadrant here. All right, so now we can find the sine of 2 theta. So let's box that one. Sine of 2 theta is going to be given by 2 times the sine of theta times the cosine of theta. So I'll begin first by plugging in the values that I know. So that's 2 times negative 4/5 times 3/5. And here I end up with negative 24/25. So the sine of 2 theta is negative 24/25. Okay, next up, the cosine of 2 theta. For the cosine of 2 theta, you can do, like I said before, a few different identities. You can pick any of those since you have the value for sine and cosine of theta. It really doesn't make a difference which one you do. I'm going to do 1 minus 2 sine squared theta, just because I want to. I have 1 minus 2 times sine theta, remember, is negative 4/5, so we're going to take negative 4/5 and square that value. So we have 1 minus 2 times 16/25. And we end up with negative 7/25 for the cosine of 2 theta. Okay, number 4 here, it says that if x is equal to 3 times the sine of theta, and theta is in your second quadrant, let's express cosine 2 theta. So cosine of 2 theta is going to be given by cosine squared theta minus sine squared theta. Okay, now, the only thing is I don't have cosine theta yet, right? So I'd have to be able to express that, or I can simply change this to 1 minus sine squared theta. So there is sometimes a definite advantage to using one identity over the other. So in this case, I probably would have wanted to start with just 1 minus 2 sine squared theta. Okay, because my given here is in terms of sine theta. So I'm going to isolate sine theta first. So I have sine of theta is equal to x over 3. And I'm going to make that substitution in here. So I have cosine of 2 theta is equal to 1 minus 2 times x over 3 squared. So 1 minus x over 9, so 2x squared ninths. Okay. So this is the cosine of 2 theta expressed in terms of x. Okay, in part B, we're going to express sine of 2 theta. So we're going to take that, use our double angle formula. We know that's 2 times the sine of theta times the cosine of theta. So this one I think is a little bit trickier than part A here because we need to be able to express just the cosine of theta, and we're not given this in terms of cosine theta. So I'm going to make the substitution right away though for sine theta. I know that that's x over 3. Now when I express cosine theta, remember from before, that was positive or negative square root of 1 minus sine squared theta. So I can plug in sine squared theta here. Since I know what sine of theta is, I can just square that value. So I have cosine of theta is equal to positive or negative 1 minus x over 3 squared. Okay. Now, when we're dealing with the cosine here, you have to really consider the fact that it's in the second quadrant here. When we were dealing with sine, because sine is positive here in the second quadrant, I didn't change the sign at all when I plugged that in. Plus, we were squaring it anyhow. But here, when we take our answer, it is important that we know that the cosine in the second quadrant is going to be negative. So I know that this value here is going to be a negative square root of 1 minus, let's see, x squared over 9. Okay. So now when I multiply this out, I have, and I can do the same thing here again where I take the denominator and I try to write this as one fraction so I can split the radical up and evaluate the denominator. So I've got 2 times x over 3 times a negative. I'm going to pull that negative out in front now. And then the square root here, and in the numerator you're going to have 9 minus x squared, and in the denominator you'll have just a 3, okay, after you combine this fraction and square root it. Alright, so this would be close to my final answer here if I want to simplify it. Your book is going to probably simplify all the way, so that's why I'm doing that as well. So I have negative 2/9 x times the square root of 9 minus x squared. So there's problem 4b. Okie dokie, last up in this lesson we're going to look at our half angle formulas. Now these were derived in part 7 of our Prove It notes, so make sure you watch the part 6, part 7 video. It's got all of those formulas from today, and it's very important that you do watch them, so make sure you go back and watch them if you haven't already done so. Okay, now the reason why the half angle formulas are actually very useful is because if I asked you to find something like, let's say the cosine of 22.5 degrees, and I asked you to find the exact answer for this as opposed to using your calculator, you might look at me like very confused because we haven't studied this particular trig value. However, we do know what the cosine of 45 degrees is, right? This is a known value for us. So by using our half angle formulas, that's really all we need to know in order to, oops, that would be this guy here. In order to solve for the cosine of 22.5, we would simply have to plug in and know our cosine of 45 degrees. So they are very useful. So the first question here that I'm going to go over, the only practice that we're going to do is with, in context to a triangle. So when we're thinking about half angles, you still have to remember where that angle exists. So think about where it is in terms of the first, second, third, or fourth quadrant. Now here, because it's a triangle, we know that these are both acute angles, so it has to be in the first quadrant. So they have to lie between 0 and 90 degrees. So our sine and cosine should be positive, okay? So anyhow, even though our formula does call for positive or negative square root, in this case 1 minus cosine of x over 2, we can assume that we're going to just keep our positive because this is, like I said, these are acute angles. Okay, anyhow, I'm going to keep that in there just so we talk about it at least again. So the sine of beta over 2 is going to be given by this formula, positive or negative square root of 1 minus cosine x over 2. So it's not both solutions, we have to pick one. And like I said before, we're going to pick the positive. But anyhow, I need to figure out what the cosine of x is. So, sorry, I shouldn't be writing x. Since we're doing this in terms of beta, we have a value here. It's the cosine of beta, right? And I can plug in the cosine of beta here because it's just 5/13. So this is going to be positive square root of 1 minus 5/13 over 2. If we simplify here, I end up with, let's see, 8/13 over 2. I'm actually not going to rationalize this. I'm just going to leave it as 8/26. So this is positive 8/26 for the sine of beta over 2. For the cosine of beta over 2, now we're going to switch gears and use the other half angle formula, and that's the square root, positive or negative square root, of 1 plus the cosine of beta over 2. So we evaluate here. We're still going to use, the cosine of beta is still 5/13, so I have positive or negative square root of 1 plus 5/13 divided by 2. This gives me positive positive square root of 8/13 divided by 2, which is going to be positive square root of 18/26. This is 26th. Can't say that word. Okay, so I'm going to leave you guys to try number 7 on your own. Okay, and just remember, you're just switching gears here. You're doing alpha as opposed to beta. Okay, nice job. I'll see you guys in class mañana.